Warahmatullahi Wabarakatuh. My name is Faiz, and then I'm from Software Daddies. So for this is for my role on this assignment is that I was in charge of the token detection. So turning the front camera feed into a list of color tokens so that it can react to. So there are three parts that I have done, which is the first capture, which is read the live front camera, TCP stream, and also decode each frame. And then the second is detection, which is applying the HSV color mask to find green, red, and also yellow tokens. And then the third, which is extracting. So filtering the noise and also the output of each token's color, position, coordination, and also the size of the tokens. So before detection can run is that we need to get a clean frame of the screen camera, which is of the front camera. So based on the code here is that the camera feed arrive over a TCP as line prefix JPEG frames. This has to be reassembled correctly before any HSV word can start. So the line prefix framing is that a 4-byte line arrive first, then exactly that many JPEG bytes follow. The TCP can split one image across several packets, so the loop keeps reading until the full frame has arrived. So why this matters for detection is that the function imdecode only works on a complete uncorrupted JPEG. A partial frame here would silently break every HSV mask downstream. So this step is the foundation of the rest of detection depends on. So going to the next, which is the feature selected. So the problem is that turning the pixel into a steering decision. So before this commit, the car had no structured way to map what it saw to where it needed to go. So we have three phases here, which is detection, processing, and also the actuating, which is the output of the processing. So detection is that finding the token is that going to apply the HSV mask per color, and then also applying the contour and also the area filter. After that, processing, locating the lane. We're going to locate the pixel CV, which is the coordination, and then convert it into a lane float. And after that, pick the best target token, which is the nearest token, so that the car can steer left or right. Actuate, moving it, which is steer toward it. So blending the lane plus pixel offset. And the second is sending the steer plus excelling via TCP. So the outcome of this is that it creates a continuous pipeline from raw camera to a steering throttle value, sending over TCP roughly over 20 milliseconds. So why this method is that applying HSV are much more better than the BGE threshold. Because the reason is that the BGR actually has the color and the brightness all mixed into one channel. So let's say a green token in shadow has different value of B, G, and R. So let's say that the green token are in shadow or even in lit, it will create a different values, which has a multiple value, while the HSV, which is separating the hue and also the saturation, which is the brightness. So HSV has a fixed hue range, which is 40 to 80, and then this hue range still matches the green color, whether it is being shadow or lit. So the result is that it creates a stable detection across lighting. This is why the ranges are kept untouched once it was proven. And so the code walkthrough here is that from masking to the token list. So the first here is about the threshold plus the cleaning. Applying the HSV mask, then erode to remove any noise specks. The second is that finding the blobs. So applying the function, which is find contours, going to extract every surviving shape. The third is filtering and also locating the blobs. So each drop tiny blobs get centered pixelated, which is going to get the CX and also the CY coordinate of the pixel. The fourth, which is the output of the token. So going to packaging all the color, position, as well as the size for the later use so that the program can actuate where the car should be steered. And so for the summary is that HSV detection turns camera frame into steering decision, capture frame, line HLV threshold, filter and also locate, and then steer and send it so that the car can move left to right between the 5 lanes. Thank you.